Space is not a void to be crossed. It is a living landscape, constantly shifting, flowing, and guiding us through pathways that cannot be seen, only felt. And so we continue, eyes fixed not on where we are, but on where gravity will take us next. For to travel through space is not simply to move. It is to surrender gently to the silent architecture of the universe itself. Mercury waits in the inner dark, a world so close to the sun that dawn arrives like a blade of white fire. To reach it, we don't speed up. We surrender speed, falling inward along a curve of light. The question isn't only how far Mercury is, but how slowly we can learn to arrive. From Earth's orbit, every instinct says, "Go faster." But the inner solar system teaches a subtler lesson. To reach Mercury, we must shed energy. Earth circles the sun at about 30 kilometers per second. Mercury whips around it at roughly 47. As we drop sunward, our heliocentric speed naturally rises. So, the real challenge isn't getting to Mercury, it's arriving slow enough to stay. That is why missions to this small, scorched world use elaborate dances of flybys and gravity assists, shaving speed with each pass until capture becomes possible. The fastest way to simply touch Mercury is a direct transfer for a flyby, historically on the order of 3 to 5 months. Mariner 10 proved this in the 1970s, taking about 4 months from launch to its first Mercury encounter. But orbiting Mercury, truly lingering there, demands patience. NASA's Messenger spacecraft, launched in 2004, looped past Earth once, Venus twice, and Mercury 3 times, finally easing into orbit in 2011, about 6.5 years after departure. Europe and Japan's Bepi Colombo followed a similarly intricate path. 1 Earth flyby, 2 at Venus, then multiple at Mercury, spending years trimming speed before planned orbital insertion in the mid-2020s. Inward is not closer. Inward is harder. Approach becomes an exercise in serenity. Each flyby is a metronome tick in a long composition, a precise brush with a planet's gravity, a quiet course correction, an incremental surrender of energy. Between encounters, the spacecraft coasts through radiant silence, the sun growing larger, harsher, more insistent. Thermal shields become lifelines. Sunlight here is up to 10 times stronger than what warms Earth. Guidance, navigation, and control systems practice a form of celestial Tai Chi. Small gestures, enormous consequences, and then Mercury fills the window. A charcoal gray world, cratered and ancient, framed by a solar glare so fierce it turns space to glass. Temperatures swing from searing to cryogenic, up to 430 degrees Celsius, 800 degrees Fahrenheit at noon, plunging below -70 degrees Celsius, -290 degrees Fahrenheit at night, with almost no atmosphere, only a fragile exosphere of atoms knocked loose by sunlight and micrometeorites. There is no wind, no weather, no softening haze. Shadows carve knife-edged boundaries. The sky is always black. Time on Mercury feels inside out. A year lasts only 88 Earth days, yet one solar day, from noon to noon, takes 176 Earth days. Stand on the surface near the terminator, and you could watch the sun creep, hesitate, even seem to reverse near perihelion, a strange ballet born of orbital resonance and rotation. Here, dawn is a geological event. Scientifically, Mercury is a paradox wrapped in extremes, an outsized iron core, a global magnetic field in a world so small, a surface scarred by volcanic plains and tectonic cliffs, lobate scarps that reveal a planet still shrinking as it cools. Each orbit maps a chapter of planetary formation written in metal and light. How long does it take to reach Mercury? For a flyby, mere months. For an orbit, years. Patient years spent peeling away speed, layer by careful layer. The reward for that patience is a vantage point unlike any other in the solar system. The innermost keep of our star, where space, heat, and time are distilled to their elemental forms. And in that stark brilliance, Mercury offers a final lesson. Sometimes the shortest distance demands the longest grace. Venus glows like a lantern in the dawn sky, closer to us than any other planet. Yet reaching it means descending into a world of crushing heat and eternal storms. How long would it take to glide through its clouds and witness a sunrise that never ends? From the surface of Earth, Venus appears serene, soft, radiant, almost gentle in its beauty. Ancient astronomers named it after the goddess of love, enchanted by its steady brilliance. Yet behind that golden glow lies a planet so extreme that it challenges every expectation we have about habitability, atmospheric pressure, and time itself. To reach Venus, we must first understand that we are not simply traveling to a neighboring world. We are diving inward toward the furnace of the sun, falling toward a planet that spins to a different rhythm than any other in the solar system. Although Venus is Earth's closest planetary neighbor, reaching it is not as simple as pointing a spacecraft directly at it. Because Venus orbits closer to the Sun, we must first reduce our orbital speed around the Sun, essentially falling inward. This takes more energy than traveling outward to Mars. We must carefully time our launch to match Venus's orbital window, which opens roughly every 19 months. When the alignment is perfect, a spacecraft traveling on a Hohmann transfer orbit can reach Venus in about 120 to 150 days. just 4 to 5 months of drifting across the void, watching the sun grow larger with each passing day. During the journey, the spacecraft is slowly captured by the sun's gravity, accelerating as it draws closer to the inner solar system. Temperatures rise, radiation levels increase, and our destination grows brighter, transforming from a distant star-like object to a world veiled in thick clouds that reflect nearly all sunlight back into space. This is why Venus shines so brilliantly. It is not a mirror. Yet it reflects more light than any other planet, glowing like a cosmic beacon in the early morning and evening skies. Approaching Venus is like approaching a dream wrapped in mystery. There are no shadows here, only a constant blanket of light filtered through the atmosphere. The planet rotates so slowly, taking 243 Earth days to complete a single rotation, that a single Venusian day is longer than its year. If you stood on its surface, the sun would appear to rise in the west and set in the east, moving across the sky so slowly it would seem almost motionless. Imagine standing on a world where sunrise takes weeks, where time stretches so far that a single afternoon could last a month. Yet, the beauty of Venus hides a punishing reality. Its atmosphere is composed almost entirely of carbon dioxide, trapping heat in an unstoppable greenhouse effect. The surface reaches temperatures of nearly 880 degrees Fahrenheit, hot enough to melt lead. The pressure is over 90 times that of Earth, equivalent to being nearly a mile beneath the ocean. Clouds of sulfuric acid swirl overhead, reflecting sunlight back into space, even as they trap heat below. Once imagined as a lush jungle world, Venus is in truth a planetary cautionary tale. But while landing on Venus may be impossible for humans today, exploring its upper atmosphere could be our key to understanding planetary evolution. At about 50 kilometers above the surface, temperatures and pressures are remarkably Earth-like. It is here in the golden haze that future balloon-like habitats could drift peacefully above the inferno below, forever watching the horizon where sunset never truly ends. To reach Venus is not only to measure distance, it is to step into a mirror of Earth's past and a warning of its possible future. The journey there may take only months, but the revelations it offers could span centuries of human understanding. Though Venus is Earth's sister in size, its atmosphere is a furnace of carbon dioxide. As we approach, we measure our journey not just in distance, but in the unfolding history of a planet that became a warning.
Earth and Venus were born beside each other, sculpted from the same primordial dust that circled the infant sun. In their earliest days, they may have glimmered with oceans, clouds, and the building blocks of life. But where Earth calmed, cooled, and nurtured life, Venus spiraled into catastrophe. As we descend toward Venus, our spacecraft becomes a time machine, tracing the divergent paths of two planetary siblings, one that chose balance and one consumed by runaway transformation. The deeper we go, the more Venus reveals not just its nature, but the delicate fragility of habitability itself. From orbit, Venus looks peaceful, its creamy clouds slowly churning in a perpetual global blanket. Yet, beneath that facade lies a world of relentless turmoil. The atmosphere is composed of over 96% carbon dioxide, with thick layers of sulfuric acid clouds that obscure the surface from view. The pressure is more than 90 times that of Earth, equivalent to being nearly a kilometer beneath the ocean. The heat reaches nearly 880 degrees Fahrenheit, 470 degrees Celsius. On Venus, metal melts in the open air. Spacecraft survive only minutes before being crushed or cooked into silence. But Venus may not have always been this way. Some planetary scientists believe it once had oceans, shallow seas that evaporated as volcanic eruptions filled the atmosphere with greenhouse gases. Without a stable magnetic field to shield it from solar radiation, Venus slowly lost its water to space. Hydrogen escaped into the void, while oxygen reacted with surface minerals, leaving behind a desert of superheated rock. Venus did not die in a sudden cataclysm. It transformed slowly, inevitably, over millions of years, proving that planets, like living creatures, can age and decay.
The winds in Venus's upper atmosphere travel at hurricane speeds, circling the planet in just 4 Earth days. This phenomenon, known as superrotation, causes the clouds to race endlessly around the globe, driven by heat so intense that the very air seems to churn with desperation. Lightning flashes within the toxic storms. Acid rain forms in the clouds, only to evaporate before it ever reaches the ground. Even the word rain loses meaning on Venus. What falls from the sky never touches the surface. As we simulate what a human explorer would experience, we find that a step onto Venus would be a step into a furnace. The skies would be an unbroken orange haze. The horizon would shimmer with refraction from the searing heat. There would be no blue sky, no stars, only darkness and the distant outline of volcanic plains. Venus is home to more volcanoes than any other planet, perhaps over 1,600 major ones, many still thought to be active. It is not merely hot, it is alive with internal fire, constantly reshaping its surface. Yet amidst this hostility lies a deeper truth. Venus is not just a failed planet. It is a mirror showing us what can happen when a delicate equilibrium breaks. The same greenhouse effect that warms Earth to life has gone unchecked here, turning paradise into purgatory.